Hello, I'm here for some geometry. Oh, my head fits right in that circle. I'm super growing restless and would rather just have you sitting here, especially since it's getting to the end of the year. And I normally we're just going to hang out and we're going to have some fun and we're going to do some math. And I really miss having you here. And so I'm going a little crazy. It's okay. Together we can do this. We're going to do section 12.5, page 830. I'm sure you can tell that I'm growing a little restless because my videos are getting crazier and crazier, I'm sure. Because I'm getting crazier and crazier. 830, section 12.5. Okay, circles. So we're going to talk about some angles and some circles again today. The first one we're going to do is right here. This one, this little rule for angles, and you can write these little equations on your card that you're going to use for your test. These ones that we're going to talk about first are going to be using a tangent and a secant, or a tangent and a chord. So remember, a tangent runs right by the circle and hits it in one place, like that. And then this would work with a tangent and a secant, or a tangent and a chord, either one. So there's my tangent. I can either do a secant, like that, or I could also do it with a tangent and a chord, okay? So actually I should have drawn this a little differently to match their picture better. A tangent could start right here, and a secant, or a tangent and a chord, like that. That's probably a little bit better of a picture, so that I can use it with the example that we're going to do on example 1. Okay, so if I need to find the measurement of an angle, like this one right here, in this situation, when you have a tangent and a secant, the angle measure is half of whatever this arc is. So arc divided by 2. So in example number 1, I know that arc is 142 degrees. So the angle is going to be half of that, which is 71. Okay, so that's how I would do that. Also in that picture, we have a right angle right here, correct? So again, the angle is half of the arc. So the arc that this makes and go all the way to the chord is this big arc. So if this is 90, that's half of the arc. So the arc would be 180, right? Okay. So if you have a tangent and a secant, or a tangent and a chord, it's the arc divided by 2. The angle is just half of the arc. Okay. Also, if you have chords that are crossing each other like this, and you need to find the angle, like angle number 1, it's the arc here plus the arc here divided by 2. So on example number 2, if this is a 32 degree, they can work with secants too, by the way. I drew chords, they can work with secants. So well, that's what example 2 is. That's okay. This is 32, this is 100. So to get this angle, remember these two angles are the same. So it doesn't really matter which one you get, they're the same thing. 32 plus 100 is 132. Divided by 2 is 66. So this angle is 66, and so is this one. Okay, so 2 chords, 2 secants, you just add the arcs and divide by 2. All right, the next one is this one over here, which is on page 832. It can be made by a lot of things. There's a secant right here. It can be made with a tangent and a secant. It can be made with 2 tangents. It can be made with 2 secants. There's a lot of different varieties of this one, okay? But I'm just going to draw it like this right now. Okay, so we're going to do an example like this one here. So that would be like, okay, I found one that would look like this one. We'll make this 83 degrees. This is 25 degrees, and this is X right here. Okay, so this one we'd have to work a little bit backwards, right? The rule is the big arc minus the small arc divided by 2 equals the angle. Okay, so let's go ahead and do that. The big arc is 83. Minus the little arc is X. We don't know what that is. It's right here. Divided by 2 equals 25. Am I still, can you still, oh yes, you can still say perfect. Okay, so we multiply by 2. 83 minus X would be 50. We subtract 83. Oh boy. Negative X equals negative 33. Did I do that math incorrectly? Where are you to help me? Negative 33. Okay, I think that's right. we get rid of our negatives and x would be 33. Is that what they asked for? Just what x is? Yep, okay, so we're good there. Okay, so on these ones, the big minus the small divided by 2 is the angle, okay? But notice on example 3, they have a tangent and a secant. That's okay, you still would do 174 minus 98 divided by 2 to get the angle. Ooh, B is tricky. Let's look at B. Super tricky. Of course, they won't trick you, I know. And valued teaching partner, I'm sure you have this well in control, but we're just going to go over it just in case somebody needs it. All right, so there's our circle. It's kind of an egg when I look at it in the video, okay? Then we have a tangent and a tangent. So let's just look at something here real quick. This is my tangent here. This is my tangent here. This is the big arc, right? This, it's not drawn very well. I know, it's a surprise, but this is the little arc, correct? So the big arc and the little arc in this circle together make the entire circle. So let's look at example 3b. The big arc, let's see, what did they give us? They gave us that this is 132 and that this is x, I think. Okay, the big arc, because it's two tangents, the big arc and the little arc make the entire circle. So if I know an entire circle is 360 degrees and I've already used 132 of it here, can I figure out how big this big arc is? Couldn't I just go 360 minus 132? Okay, and I think they did that for us. It's 228. So now I can go the big arc minus the small arc divided by 2, and that will give me what that angle is, which is what they're looking for. Okay, so you can put that into your calculator. It says you should get 48. So on those circles that have two tangents, the two arcs together make 360. So you can use the one you're missing to figure out what the other one is. Okay? Okay. Let's look at the top of 833. Well, I think it just goes over what we just did. Yeah, it just is a place where you can get all of the equations in one place. Okay, let's look at example number 5. Find the measure of arc AF. Okay, well, AF. Oh, I better draw it. AF. I lost my place. There we go. Okay, we got a circle. We got a bunch to draw. Wow, I should have drawn this before I started this video. Okay. It's B. I think this is A. I think this is C. And this is 110. And then we have D, E. I think this is E. This is D, maybe. Oopsie, I lied. This is not. I'm sorry you're having to sit here while I watch this, while I draw this picture. F, this is 48 degrees right there. And this is 160. And we're looking for AF. We're looking for this right here. Okay, great. Well, I know this arc plus this arc divided by 2 would make this, but I don't really know what that is, right? I know this whole thing is 110, so when it, remember this is half of the arc here, so 110 times 2 is 220, right? We already have 160 of it, so would that be for 50, 60 more right there? Great news. Look at this, it's working. Oh, you can't even see me, just my hands. So 60 plus 48, correct? Couldn't I do that to get this angle right here? 60 plus 48 is 108, right? Divided by 2. Oh, I think they're doing it a different way. I think we should be able to get it this way though. I know, okay. So 60 plus 40 is 108. 48 is 108, right? Divided by 2 is 2 is 5, 54. This is 54. Together, this one and this one make 180, right? So 180 minus 54 is, I don't have a a calculator in front of me and my brain is not working today. 126. So this angle is 126 right here. I might have gone about it the longer way, but we should still get there. Okay, so 126. So now my rule is this arc plus this one, which is a mystery one, divided by 2 equals the angle. Okay, so you can math that. You can multiply by 2 equals times 2 is 12. See, I can't even do this, you guys. 152. Did I do it right? Well, you can math that for me because I'm a disaster today. Okay, so math that, and this arc plus this arc divided by 2 makes this angle. You work backwards, you go, and you should get 92. Let's see what way they did it. I'm curious. How much time do I have left? I still have time. Okay. They did that. They got, that was 220. Yeah, we did that. Okay. ADB, we did that already. They did AD. Yeah, we got that as 60. Yeah, we did that. And then they said, oh, they just did this. I made it much longer. They just did this. Ha! I should have done that too. Sorry, guys. They did this. 360 minus the 48 that we have right here. The 160 I have right here. The 60 I have right here to get what they have left. I'm a total disaster. That's a much easier way to do that. But I gave you a more complicated, better education because I showed you a crazy way to do it. Okay? But they got this, and they subtracted it from 360 to find the missing part. That works too, I guess. Okay. Wow, sorry. It's Wednesday by chance that I'm videoing this, so that's really funny to me because you know how Wednesdays are around here. I know you're not doing it on a Wednesday, but I'm filming it on a Wednesday, and that's funny. Okay, so that's all you need to know. Let's have some math humor. Okay. Question: why was the cord upset with the tangent after the race? Why was the cord upset with the tangent after their race? I know, I can see Elijah right now going through all of the vocab terms to find the correct answer. Why was the cord upset with the tangent after their race? They came in second. So yeah.